Hello, student. Welcome to all of you. Now, this is the physics lecture. Myself, Rajesh Lagat, physics teacher in Sri Shivaji Vidya Mandir, Aun. Now, we have to start here the second chapter in our physics subject. The name of the chapter is the mathematical methods. That means we have to study here the scalars and the vectors. First of all, we have to see here what is meant by the scalar and what is meant by the vector. You know that well. The scalar means what? Those physical quantity which can be described its magnitude alone, which is called as a scalar. For example, length, mass, time, etc. Then vector means what? Those physical quantity which can be described its magnitude as well as direction is called as a vector. And the example for these vector quantities are displacement, velocity, acceleration, force, etc. Then what is the distinguish between the scalar and vector? This is also very simple point. Then we have to see here the some terms just like the zero vector, that is also called as the null vector, resultant vector, negative vector, that means opposite vector, equal vector, position vector, unit vector. That are the some terms which are very important while solving the numericals in that chapter. So that first of all we have to see here what is the distinguish between the scalar and vector. The scalars are added or subtracted by the rules of algebra. This is the very main distinguish between the scalar and vector. You remember this distinguish. Scalar can be added or subtracted by the rules of algebra, and vectors cannot be added or subtracted by the rules of algebra. Then second one is that the scalar cannot be represented by an arrow. Scalar cannot be represented by an arrow. Just like here, the scalar we can write here only this A. The arrow is not there, then this is the scalar. Okay. And if you write here A bar, then this is the vector. That means the vector can be represented by an arrow and the scalar cannot be represented by an arrow. Another distinction is that the scalar cannot be represented by the graphically representation. Graphically representation is not allowed in the scalar quantities, and vector can be represented by this graphical representation. And one distinction is that they define the scalar and vector, and examples of this scalar and vector here you can write also. That means if you have to write the four distinguish, then you get 2 marks. Each distinguish there should be the half marks. Therefore, this is the 4 distinguish between the scalar and vector. Once again, remember that the scalar, those physical quantity which can be described its magnitude alone, known as a scalar or the scalar quantity. For example, length, mass, time, etc. Vector, those physical quantity which can be described its magnitude as well as direction, known as a vector or the vector quantity. For example, displacement, velocity, acceleration, force, etc. Now, this is the main distinguish, that is the definition between the scalar and vector. Now, second distinguish is that scalar can be added or subtracted. Scalar can be added or subtracted with the help of the rules of algebra. With the rules of algebra, scalar can be added or subtracted. But this vector cannot be added or subtracted by the rules of algebra. We have to see here why this vector cannot be added or subtracted by the rules of algebra. This is another question. Okay. Now, third one is that the scalar cannot be represented by an arrow. The arrow should not be allowed while writing the scalar. Scalar cannot be represented by an arrow, but the vector can be represented by an arrow, just like the bar, just like the cap. You can write also this a bar, this is also vector. You can write this a cap, this is also vector. That means the vector can be represented by an arrow. Also, last one is that this vector scalar cannot be represented by the graphical representation, and the vector can be represented by the graphical representation. Okay, this is the small distinguish between this scalar and vector. You understand this both quantity well by this distinguish. Okay, now we should see here there are the different terms which are in your books, this chapter. These are the we have to see here. The first is the null vector. What is meant by the null vector? This null vector means what? A vector having the zero magnitude. A vector, it has a zero magnitude with a particular direction. It is called as a zero vector. Okay, and this vector is the stationary particle, which is a zero vector, or the acceleration is moving with the uniform velocity, which is also zero vector. Now, second one is the resultant vector. What is meant by the resultant vector? The resultant of two or more vectors which is given by the single vector. That means the resultant of the two or more vectors which gives the single vector known as a resultant vector produces the same effect. There is no change, and which is produced by the all the vectors together. Now, next one is the negative vector. What is meant by the negative vector? Which is also called as the opposite vector. That means vector a bar as the negative vector minus a bar. This is the negative vector. But we can, this vector can be denoted by the opposite direction. This is nothing but the negative vector. A vector, negative vector of a given vector is a vector of the same magnitude but opposite in direction to that of the given vector. Here we have to see here the vector a bar which is in lies in this direction, and b bar is in opposite direction. This is nothing but the negative vector. Now the equal vector. What is meant by the equal vector? The two vectors a bar and b bar representing the same physical quantity are said to be the equal if and only if they have to same magnitude as well as direction. And these two vectors are shown here. This is the opposite vector because direction is opposite, so that this is a negative vector. And equal vectors, they are showing the same direction. This is the equal vector. Now the position vector. The position vector means what? You have to represent here the position vector small r bar. This is nothing but the position vector. A vector which gives the position of that particles at a point which respect to origin and chosen the coordinate system is called as the position vector. In this coordinate system xy, this OP is the position vector denoted by the small letter r bar. Now the unit vector. Next term is the unit vector. What is meant by the unit vector? A vector having the unit magnitude is called as a unit vector. A vector having the unit magnitude also given direction which is called as the unit vector. That means if you have to take the a bar, then a is equal to mod of a bar, or here if m bar is a non-zero vector, then simply m in magnitude form, this is nothing but the mod of vector m bar. This is the not zero. This is the unit vector which is also given by this given vector and divided by its magnitude. This is nothing but the unit vector. The formula for this unit vector we can write here. If m bar is the written as the u magnitude form, and it is given by m bar is equal to this unit vector into m. Therefore, this unit vector u cap is equal to m bar upon m. M is a given vector in a direction and m is its magnitude. And we have to find out also in this numerical by using this formula, we can find out the unit vector. Okay. Now, next point in that chapter we have to see here why the the vector cannot be added or subtracted by the rules of algebra. For one example, we have to see why this vector cannot be added or subtracted by the rules of algebra. We have to take here this example. Suppose we have to take here the two vectors, vector a bar and the vector b bar. This is the vector a bar starting from this, and second one is this vector. This is the b bar. This vector a bar having the magnitude 4 meter and b bar having the magnitude 3 meters respectively. Okay, and the resultant of these two vectors is nothing but, we have to draw here this diagram, and this is the resultant vector r bar is equal to a bar plus b bar. We have to write only r bar also, and this is nothing but the 7 meter. This is the figure A. Okay, we have to consider here, if the two vectors a bar and b bar having the magnitude 4 meter and 3 meter respectively, then their resultant is of the 7 meter. But why? If these two vectors are in same direction, we have to write here this direction is the same direction. This is very important. If the two vectors a bar and b bar having the magnitude 4 meter and 3 meter respectively, and they are in same direction, along the same direction, then their resultant is of the 7 meter respectively, as shown in figure A. Suppose we have to take here the another vector, this a bar, vector a bar having the magnitude 4 meters as above, and another vector b bar, and which is the magnitude 3 meter respectively, but its direction is in opposite direction. Okay, then their resultant vector is of just like this, and this is the resultant vector and its magnitude is 1 meter, and this is the figure B, and these two vectors are in opposite direction. We have to write here in opposite direction. Okay, secondly, we have to write here, if the two vectors a bar and b bar having the magnitude 4 meter and 3 meter respectively, and they are in opposite direction, then their resultant are of the magnitude 1 meter, as shown in figure B. Then also we have to write here, if the two vectors, they are the mutually perpendicular to each other. Suppose this is the first, this is the second, and this is the third one. If these two vectors right there, they are the mutually perpendicular to each other. Suppose this is the vector a bar having the magnitude 4 meter. This is the second one. This is the 3 meter b bar vector, and these two vectors are mutually perpendicular to each other. Then their resultant, we have to write here, see here, this is also the magnitude of 5 meter. This is the r bar. How it can be solved? Therefore, we know that by using the Pythagoras theorem, this resultant r square is equal to 4 square plus, see here, 4 square plus 3 square. 4 square is 16, 3 square is 9, that is 25, r square is equal to, therefore r is equal to 5. By using the Pythagoras theorem, we can write, if the two vectors are mutually perpendicular to each other, then the resultant is the 5 meters. By using the Pythagoras theorem, we can find out this. This is the figure C. From this three consideration, above consideration shows that the vectors cannot be added or subtracted by the rules of algebra. If the two vectors which are in same direction, resultant is 1 meter. Resultant is 7 meter. If the two vectors are in opposite direction, the resultant is 1 meter. If the two vectors are mutually perpendicular to each other, then the resultant is 5 meter. This consideration shows that the vectors cannot be added or subtracted by the rules of algebra. From this example, we can write this. This vector cannot be added or subtracted by the rules of algebra. Okay. Now I said the next lecture we are stop here.